Good morning, students. In the previous module, we have studied about reaction of metals with oxygen and analyzed the order of reactivity of metals with oxygen. Now, we are going to study about the reaction of metals with water. Depending on their chemical reactivity, some metals react with cold water, whereas some react with hot water. Much less reactive metals do not react neither with cold water nor with hot water. They react with steam. The least reactive metals like lead, copper, silver and gold do not react with water at all. Metals like potassium, sodium, calcium react with cold water, forming the respective metal hydroxide and hydrogen gas. Magnesium reacts with hot water, forming magnesium hydroxide and hydrogen gas. Aluminium, zinc and iron cannot react with hot water but react with steam to form metal oxide and hydrogen gas. The reactions of potassium and sodium with water are highly exothermic and cause explosions. Hydrogen gas catches fire and burns due to the heat produced. The piece of potassium or the sodium metal, when placed in a glass trough filled with water, starts moving in water, making a hissing sound and reacts with water, causing explosions. The piece of metal also catches fire. The heat produced burns the hydrogen gas as well as the metal. So you can see in the image how sodium and potassium react with water vigorously, catching fire. Now, calcium is not so reactive as potassium or sodium. It reacts with cold water readily. It is an exothermic reaction, but the heat produced is not sufficient to burn the hydrogen gas. The piece of calcium metal starts floating in water because the bubbles of hydrogen gas formed during the reaction stick to its surface. Magnesium reacts with hot water. It is less reactive when compared with calcium. It reacts with hot water, but the piece of magnesium metal also starts floating in water due to the bubbles of hydrogen gas sticking to the surface. Much less reactive metals like aluminium, zinc and iron, they react with steam to form metal oxides and hydrogen gas. For the chemical reaction of the metals with steam, the following apparatus is set up. A lump of glass wool soaked in water is placed at the bottom of a boiling tube. The water present in the glass wool will form steam on heating. The glass wool itself does not take part in the reaction but provides the steam for the metal. The metal sample is placed in the middle of the horizontally kept boiling tube. The glass wool is now heated by a burner. The water present in the glass wool forms steam on heating. This steam then passes over the metal. The hot metal reacts to form the corresponding metal oxide and hydrogen gas. The hydrogen gas comes out of the boiling tube and it is collected over the water. When a lighted matchstick is taken near the gas jar, we observe that the gas burns with a pop sound, indicating that the gas evolved is hydrogen. The metal oxide formed remains behind in the boiling tube. So we have seen that some metals are reacting with cold water, like potassium, sodium, and calcium, where magnesium is reacting with hot water. Aluminium, zinc, and iron react with steam. Still, less reactive metals like lead, copper, silver, and gold do not react with water at all. Now, if you see the chemical reactions of metals with water, it's easy for you if you learn the general equations. So, metal plus water. Here, the water can be taken either to be cold water or hot water. We get metal hydroxide plus hydrogen gas. Metal plus water in the gaseous state, that is metal plus steam, we get metal oxide plus hydrogen gas. Now, if you remember the general equations and if you know the valencies of the metals, it's easy for you to write the chemical equations. So, potassium plus water, we get potassium hydroxide plus a lot of heat is evolved. It is a highly exothermic reaction. Same with the sodium metal. It also reacts with cold water, forming sodium hydroxide, NaOH, and hydrogen gas is evolved. The heat produced is so high when potassium and sodium react with water that the hydrogen gas evolved will catch fire and even the metal starts to burn, producing a hissing sound. Calcium is less reactive comparatively with potassium and sodium, but still it reacts with cold water, forming calcium hydroxide and hydrogen gas. Magnesium reacts only with hot water to form magnesium hydroxide plus hydrogen gas is evolved. Now, comparatively less reactive metals like aluminium, zinc, and iron, they react with water to form the respective oxides. The only difference is when metals are reacting with cold or the hot water, you are getting metal hydroxide and hydrogen gas. When metals are reacting with steam, we are getting metal oxide plus hydrogen gas. Now, we can study the chemical equations of aluminium, zinc, and iron. Aluminium reacts with water to form aluminium oxide Al2O3. Zinc reacts with steam, forming zinc oxide and hydrogen gas. Iron also reacts with steam to form Fe3O4. This is known as iron 2,3 oxide. It is a mixture of iron 2 oxide and iron 3 oxide. All three of these metals, aluminium, zinc, and iron, react with steam, forming their respective oxides. The common factor is hydrogen gas is evolved. And we have already learned that hydrogen gas can be tested by taking a burning matchstick near it. If it burns with a pop sound, it confirms that the gas evolved is hydrogen gas. Lead, copper, silver and gold do not react with water and are the least reactive at the bottom of the reactivity series of metals. In the next module, we are going to discuss about the reactions of metals with dilute acids and a metal salt solution of another metal. How one metal reacts with salt solution of another metal. So we will conclude our class here today and continue with the remaining chemical properties in tomorrow's class.